Let's have a look at the valve assembly exercise in Accessible Assemblies lecture number 2. So the question says, the detailed drawings of the components used in a stop tap are shown in the following figure. Assemble the components and create the following drawings of the stop tap. A full section principal view and an external bottom view. Add the relevant dimensions and include a part list with appropriate part names and numbers. Note, the two O-rings are made of rubber, so that would be a non-metal, and they flatten out to seal against fluid leaking out. So here we have the actual question. At the top left we've got a small circular, almost like a donut shape, which has a diameter of 3 for the size of the cross-sectional circle, and center to center it's got a distance of 16. There's another one which is a bit smaller, 12mm center to center, also diameter 3. Here we have two views of a little washer, but this washer is flattened on the one side and it's got a little protrusion on the other side. It has a thickness of 2.5mm. Here we have a nut. It is a M3 nut, 10mm wide head, and the nut itself is about 4mm high. Here we have the body of the component. This is the biggest part. It is more or less like a ball shape in the middle, with a thread on the one side and a thread on the other side. And on this left hand side it also has a hexagonal feature. So this is the bottom view. In the bottom view it's got a little groove that's cut out that spans an angle of 90 degrees. In the main view the hidden detail shows the diameter 40, that is why I said it has a ball shape in the middle. Then it's got a cone on the inside. At the bottom the cone has a diameter of 12, angle of 97, and there's a 6mm hole all the way through the middle of the component. On the right hand side is a M24 by 2. Just for interest, the by 2 is actually the pitch of the thread, so that is the distance from one peak of the thread to the next. And inside of that there's another cone shape, angle 75 degrees with a big side of 16. On the other side of this component it's got an M16 thread, and we're just given where the radii are located at 36mm apart. Beneath that we've got a nut, but this is a special nut. On the right hand side it's actually got a smaller hole than what the rest of the nut is. This hole has a diameter of 15. Overall length for the nut is 18. Thickness at the right hand side is 2.5. It's got a M24 by 2, which we have seen before, and the nut has a width of 30. Beneath that there's a component that is a cylindrical component, so it's symmetric about that axis. That's why we can actually get away with only one view of the object, because these dimensions with the diameter symbol indicates that it is actually cylindrical. It's got a cone on the one side with a big side of 17, cone angle 75, 6mm hole through the middle, length of 16. This cone over here had a length of 14. We'll get back to that in a couple of minutes. Last component is this handle shape, which has a conical part over here. At the bottom is a thread, and the dimension for that thread is not given. Here we've got a diameter 3 little hole, and it is from center to center 12mm. We've seen that before somewhere. diameter 3 and 12 from center to center. This one over here is 8 and 8, 16 from center to center, diameter 3 as well. And it's got a diameter 7 hole drilled through the middle. Overall height is 31 and the angle is 83 degrees. Okay, so 83 in that angle, if we insert this handle into this cone, if that's 97, it means this side would be 83. So let's have a look how this thing will come together. There we've got the body of the component. There is the handle with the O-ring grooves and the diameter 7 hole through the middle. There we've got our little rubber O-rings, our washer, our nut, and it seems like there was a typing error in the question. That should have been M6. Looking at this nut, I was wondering that there must have been a typing error because that cannot be 3 if that overall length is 10. I think with the person who set up this question, it was radius 3, which would be diameter 6. So that nut is a M6. Okay, here we've got the cone on that side. This cone has a big side of 20 and the diameter on this side is 14. This nut has a hole through the middle of 15. Remember we said that 75 would correspond to the 75 over there. So this cone angle with the 75 would work together with that cone angle of 75. But if you check the dimensions, you would see that this big side of the cone is diameter 17, and in this question, or this part in the question, that diameter on the big side is 16, which means that this cone of ours can't go in all the way. It will stick out a little bit. Good. Next one we saw was this M24 by 2. So this nut could go over the end of this body of the component, M24 by 2. It had a 15 hole through the middle. This cylinder had a diameter of 14. So it would actually fit if I took this nut bring it in line and then screw it over this end until the inside of the nut makes contact with this flange of the green component. So basically as I tighten this nut, it will pull this cone into that cone, causing a good seal. Now we also said that these O-rings of ours could go in their position over there. So we'll first put the O-rings in place. And then once they are in place, we'll take this handle and let this cone match in to that cone. We will also tighten it all the way until these O-rings have flattened down to cause a very good seal between the fluid and the outside environment. Now if we look at this thing from the bottom, this washer could go at the bottom somewhere over there, and what will happen is if this washer is inserted in its place over there, this little protrusion will allow it to only rotate 90 degrees. So it will be able to rotate from contact on this plane to contact on that plane, but it won't be able to rotate more than that. This flattened portion of the washer would match up with that flattened portion over there, and the nut will be used to keep it all in place. Let's quickly assemble everything and line everything up and see what it will look like. So, this cone gets inserted up to the point where it makes contact, leaving a small gap over there. The reason why we wanted to make contact on the cone is as you tighten this nut, the cone will be forced into the other cone, which will give you a very good seal. There we've got the nut at the bottom and the washer, which will limit the movement of this handle to 90 degrees. Can only swing it 90 degrees, it can't spin all the way around. And then the O-rings are there to just seal it off a little bit better. So this is basically the overall assembly of the valve, and now we can go and draw it. So back to the question, we've now added all of the parts into our assembly drawing, and then we can make a drawing of this. So there we go. Over here we've got the main view, which shows the little nut, the special washer, the flattened O-rings, a little broken out section to show that the valve is in the open position with fluid being able to flow through all the way, the connector on the right hand side which is inserted into the tapered portion with the nut, threading on the left hand side. The threading on the left hand side is there so that we can use this as a functional dimension to be able to use this assembly in some other tap construction. The bottom view is over here. We have our nut on the end of the shaft with the washer, which limits my tap rotation. The 90 degrees would act as a functional dimension, and then the rest are just overall and functional dimensions. So that was basically the memorandum for the tap, which was semester test 2 of 2014, for those of you who were wondering. Functional dimension as well at the top here would be the handle dimension. Good, so that is it for how this tap comes together.